you. It's a pleasure to be here today. And if I had to give my presentation a nickname, it would be Break Down Barriers, Breakthrough Bottlenecks to Achieve Breakthrough Medicines. So if anybody asks you, it's all the B's. Typical disclaimer that I just have to say, I'm going to go through that quickly. I need to start here, though, first. What are the business drivers, those critical business drivers of the industry? Getting new products to market faster, pipeline acceleration. Being able to manufacture multiple products in a given facility, whether it's a clinical facility or a commercial facility or a CDMO, being able to do those quick changeovers and pull in new products fast. That's flexible manufacturing. Operational integrity is about reliable supply, making sure I don't have equipment breakdowns and that I can do things as much as possible right the first time. Real-time release is pretty self-explanatory, but get that product out the door as soon as possible after it is manufactured. And then finally, we want to be responsible citizens of our planet and use energy wisely, so sustainable operations. Most of my presentation is going to focus on pipeline acceleration, but we'll have a few smattering things here and there that kind of overlap with these other items as well. Why are we all here? Why does it really matter? Solving tech transfer challenges make a big difference in the world. They make a big difference in patients' lives. But rather than hear me talk about it, I want to introduce you to another person who can give you a good experience about that. His name is Chris White, and he is a survivor and patient advocate. So he's going to tell you, he was a TIL therapy recipient of the last clinical trial. So he got into a clinical trial.
You got to imagine all the, not just planning and logistics, that either, somebody's doing manually, all this evolving like technology and automation. And when it comes down to it, I mean, it all, is due to one, like make it correct, because there is no time for your batch to go wrong, so the goal is to get it, grown as fast as possible and get it back to the patient and to make sure it's done right, because there is no second chance. Or even remove some of the steps along the way, by involving like technology or, industry collaboration, that sort of stuff, but if it's now in your backyard and, you can get it to you faster, that's time and that's lives.
That's time and that's life. But I'm gonna back up for a second and look at some numbers. 10,000, 30 million, 95%. There are 10,000 rare diseases out there that affect over 30 million people in the United States, and 95% of those diseases have no approved therapy. This, yes, is why we're all here. You can see there's a lot of clinical trials ongoing right now for rare diseases and other diseases as well. And the pipeline is shifting. It's shifting from being traditional small molecules to having more large molecule and advanced therapies. These are exciting times that we're in with the advance of science, the advance of technology. We have the ability to break through those barriers, break through those bottlenecks. Most of you are in the business of saving lives. And if you're not in the direct business of providing products that save or change people's lives, you're here because you support that business in some way, whether you're an OEM equipment supplier, an automation supplier, a material supplier, or a consultant. So it is a tricky puzzle for us to figure out. We are the automation supplier that I just mentioned historically, but we've recognized it's more than just about automation. We are transforming our business to meet the needs of the industry to help get products to market faster, and it is more than just automation. So, in the next several slides, I am going to talk about a challenge, a technology solution, and some of the benefits that can be achieved by applying those technology solutions. First challenge, knowledge transfer, defining that process. You're doing that in process development and even through the clinical manufacturing. What are those challenges? A lot of times we're doing this on paper, or we have manual processes, we have Excel spreadsheets, we have databases. There's a lot of information in a lot of different places. It takes time, effort, and people to be able to go through and decipher all that information in order to be able to transfer that to the next stage. With technologies such as a process knowledge management solution, you can have a single source of truth for your recipe, for your critical process parameters, critical quality attributes, critical material parameters, the specific steps that have to happen in your process. And you can build out a library of standards that you can then use as you develop additional products that are similar to that platform. When we can do this, we can break down one of the barriers and be able to achieve sharing that data and that information across multiple facilities and across different products that might be using the same platform, or even different products that might be using similar kinds of equipment. We can replace this process specification tech transfer report with an enterprise recipe solution, and ultimately reduce time to market. I mentioned library, because when you start with a library, you're now honing in on definitions. You have an ontology. You have definitions on what I call things. Instead of calling this pH set point in one place and pH SP in another, and trying to reconcile that, if you have a library and you're starting with a library, which we have in process knowledge management solution, you're actually able to build out your process model, your physical model, your parameter models, your material models, et cetera. And then you can use that to have consistency across your process development, clinical, and commercial manufacturing. You can build out your step names and your actions, and again, being consistent across what you do. And define your equipment subclasses and be able to use that throughout your facilities. Next challenge. Once I've defined my process, now I need to decide, where am I going to manufacture it? Is it a clinical, whether it's a clinical facility, a CDMO, or if I'm ready to go into commercial manufacturing, I need to understand what my gaps are in what I need and what my facilities have to offer if I'm going to do it in an existing facility. So some of the challenges there, if you have ever, has anybody ever done that whole arduous process of doing a site facility fit? Yeah, it can be challenging because you have to understand what equipment you have at that site. Were there changes made? Does it have this capability? Does it have cooling on the jacket? What's the volume of all the equipment? And all that has to be managed and captured somewhere, and you need to be able to know what I need to be able to transfer that. And you have to identify the gaps. And then once the gaps are identified, of course, you figure out if you're going to make it there, rectify those, make some changes in the facility to make that happen. But what if, with one click of the button, you could identify what the gaps are? Well, that's what a process knowledge management solution can help you to do. And by doing so, again, you're breaking down a barrier. You're breaking through a bottleneck to get product to market faster. Okay, so now I know where I'm going to make it. But what about like all these site systems? So I might have, if I'm going to an existing facility, I might already have a DCS there, or a process control system. I might already have a manufacturing execution system there. Or even if I'm going to a new facility, I have to figure out all these parameters that have to be sent to all these different systems. And managing those parameters, those thousands of parameters, and making sure that you input the right parameter in the right system for the right parameter name in that system is quite tedious and very challenging and prone to error. It requires a lot of documentation and change management. What if, with several clicks of a button probably, you could be able to transfer that information? You have standard building blocks within your process knowledge management solution, within your distributed control system, and within your MES system, LIMS, whatever. And you're able to then be able to transfer those parameters more easily and quickly. Of course, then again, we're breaking down that barrier to be able to transfer products faster, to be able to bring them to clinical manufacturing, to commercial manufacturing faster. And then you only need to deal with change management for those parameters that have changed. Some are going to be equipment specific and don't change. You don't have to worry about those. Validation becomes easier. So there's a lot of great benefits that happen for being able to do something like that. Now I'm going to introduce the process knowledge management suite solution just briefly here. This is just a couple fuzzy screenshots. Sorry about that, but the process parameter definition, this is where you're defining the process, the critical process parameters, well, the steps, the critical process parameters, critical quality attributes, et cetera. Some of the things that have to happen in your process, maybe the equipment that's required. Formulas for scaling, for example, could also be defined, or for when you harvest, those kinds of things. You're using reusable components and building blocks so that when you make your next product that is very similar, you're able to use those same functionality. And then you can propagate that from a platform or a master platform recipe to a specific product recipe to a site recipe. Of course, when you do that, you're also managing change like any good GMP system. And one of the beautiful things, like I mentioned earlier, in order to transfer parameters, you have to be able to integrate. So, of course, there's integration capability with MES, SAP, or ERP, LIMS, whatever. Another key component is assessing risk. And we look at how do you assess the risk, what critical process parameters, quality attributes so we have to define and manage, and how do we mitigate that risk, and that's another application within this suite. Okay, so now we know what we're going to make, we know where we're going to make it, we've transferred all the parameters, but one of the other things that we probably had to think about as well would be, can I make enough at that facility? Do I have the capacity at that facility? Even if it's a new facility, am I gonna have the capacity? Another tool that you can use is some discrete event simulation capabilities to help assess if you can simulate the model then to see if you can meet that capacity. You can look at hidden bottlenecks. You can look at what my resource conflicts are. Again, breaking down a barrier so you can accelerate facility ramp up. You know where the bottlenecks are. You know if you needed a new CIP skid before you went there. You know if your WFI capacity was going to meet your goal. You know if you have the right resources, and you know the best or the way to optimize your operations in terms of 24/7 or how you're going to run the facility and how many people you need because you've modeled it. So now we get to the next challenge. What about my equipment and my processes, and I'm running a process, and when's the optimal time to take care of maintenance? And how do I make sure that I don't have an equipment issue in the middle of a manufacturing run? So with scheduling tools that use those models that you can build for your schedule of your process that you've already built when you did capacity analysis, for example. You can actually integrate them with your shop floor systems, such as your DCS and your MES, bubble up that real-time information so I at all times know exactly what is happening on the shop floor, and I can see where I have white space. When I get a failure agent tell me that I'm going to have an equipment issue in a week or a month, I can look at my schedule, look at the white space in the schedule, and schedule that maintenance activity. Again, breaking down a barrier so that you have improved equipment reliability. You can reduce maintenance costs because now you're not doing unnecessary maintenance, but you're only doing necessary maintenance, and you have improved production efficiency. Okay, on to the next challenge. But first, let me talk about real-time scheduling. That's the model that we were just talking about, where you are able to take all the information from your facility and use the data from your facility as well as some modeling tools to be able to build out a model. These models are very complicated because our facilities have a lot of interactivity, a lot of different things, interdependencies. So you can imagine a human trying to figure out that model. It's a bit crazy. So that's the modeling capability. It's, again, integrated with those other systems on site, so you're bubbling up that real-time information that I mentioned. We talked about the capacity and debottlenecking capability. You can, in real time, see exactly what's going on with your schedule. You can see what your planned schedule was. And when you have that uh-oh moment of what really happens in manufacturing, you can see what is predicted to now actually happen. And then you can see how long it's going to take you to get back on track. Now we're on to the next challenge. Right first time in manufacturing. It's hard. I worked in manufacturing in the 90s. We had paper. I looked at these batch records, hundreds of pages with all these things that we had to fill out, and we're expecting operators to do this right the first time. It's a disaster. And when something can go wrong, it will. We celebrated when we had a month of no deviations. It was an amazing thing. Whatever we can do to help eliminate these errors and the cumbersome processes of paper helps us to be able to release products on time and to minimize errors and minimize deviations and those kinds of things. So with a workflow execution tool, with a manufacturing execution system, we're able to improve right first time by ensuring that all those right things happen. I'm using the right equipment in the right state. It's still clean, it's still sterile, for example. I'm using the right material that's released, I'm using the right quantity at the right time. I'm doing everything in the right order. Unlike one time in manufacturing when they actually pulled a page out of the batch record, flipped it over, and skipped a step. Bye-bye product. So the other thing that's beautiful about a manufacturing execution system is you can flag deviations in real time, and while the operator is still standing there and the supervisor's around, you can start to investigate what really happened. So with all that visibility, with all that better right first time, we're able to prevent product losses and reduce discards, reduce those deviations, release batches faster, and reduce inventory carrying costs while we're at it. So manufacturing execution system, how many of you have an MES? Couple, okay, some of you don't. So I'm gonna step through this real briefly. It's basically your electronic batch record. It is your workflow stepping you through, so you can barcode scan the material, barcode scan the equipment. I'm doing the right thing at the right time, and I'm flagging when I have a problem. And the quality review is the ability to actually look through the batch record before it's complete in real time, make sure everything's still good, automatically flag some deviations, and start investigating them and manage it right away. A good MES also has the ability to track materials on the shop floor, not replacing the ERP. ERP has its place, but making sure I'm using the right material at the right time and documenting what's going on in ERP. Equipment management, again, managing the equipment to make sure that it's maintained, that I am using the equipment at the right time. It's the right equipment. And you're able to actually manage some workflow of what's the cleaning process, for example, or what material did I use to clean the equipment. All those things can be used and managed from equipment management. Of course, we have to integrate, because we don't have all the information in MES. You need ERP to tell you what orders you're supposed to run. You have to take samples and send them to LIMS, et cetera. So, of course, integration is important as well as user management, security, and all those typical things that you have in a good system. So that's a quick overview of MES. What else do we need to think about when we're building a facility? And we want to make sure that we are setting ourselves up for success, breaking down barriers so that we can get new products to market as quickly as possible. Well, automation, data context, and real-time control, even when it's difficult. Because sometimes getting access to that data, if it's buried down in some piece of equipment without the batch context, can be very difficult. You can have very siloed data. Additionally, if I'm trying to understand all of my critical quality attributes, some of them are easy to measure, and critical process parameters, some of them are not so easy to measure. And so when we can use those spectral analysis and be able to pull that right into the process control system, you're also then able to manage in real time the control of those critical quality attributes. And so when you're able to unlock that data and manage those critical control and do that in real time with advanced modeling and advanced process controls, you can more reliably supply good quality product and get tighter control of your critical process parameters and prevent any batch losses even more. Good control system. We live in a batch world still, mostly. There's a few continuous processes out there, but has good batch controls, has a good operator interface, is able to integrate with other systems because everything isn't necessarily right there in that process control system. So you need, an example would be OPC UA. We need to be flexible. I might want to start small, and maybe it's a little OEM piece of equipment that I'm playing around with in the lab, but then I want to be able to grow. So the flexibility from a licensing perspective, from a growing of the system perspective, from easy adding of additional equipment and growing across your network is very important. We talked about data and data context. Making that data available to the enterprise with the right context so that you can do continuous improvement, learn from your manufacturing, and take that information back even into research when they're developing a new process. Gee, that's another way to break down the barrier so that the next new product can learn from what's already happened in manufacturing. And then I mentioned being able to, in your control system, actually measure in real time some of those harder to control critical process parameters or quality attributes using things like spectral data, and then having a model within the control system that in real time is converting that into what the critical attributes are with all the great statistics associated with that, and then be able to in real time manage the control of that process. So everything I talked about right up to this point is available today as technology today that can help to break down some of those barriers. Now I'm going to think a little bit more about the future and maybe a teeny bit outside the box. We're doing some of this today as we think about all these crazy integrations that we have from all these different systems and moving that more into a streamlined data fabric view, having a backbone as the way to communicate across all these applications. But we do envision a future where that is easier, where we have applications that are available to use the data and add context to that data, like a material, for example, which is used in multiple systems. Why do I define material in 20 places? Is there a way, an easier way that we can manage that? There is, and we're moving in that direction in the future. Again, to accelerate tech transfer, reduce release times, and minimize errors. That makes me wonder, what if? What if we could unleash more AI capabilities? People have been talking about AI all week. I think there's some really cool things that people are already starting to do, and there's a lot of ideas of where it could take us. But what if, when I came into work, that I could say, hey, instead of saying, hey Siri, hey life sciences virtual advisor, what do I need to do today? And it could say to me, oh, you had a deviation. You really need to look at this. Or, oh, they finished the experiments over in the clinical or in the process development lab. We feel like you're probably ready to do a transfer. Can we go ahead and transfer those parameters? Okay, great. Take me to that app. Let's do it. Why do we want to do that? Because we want to focus our brains on things that are not routine, not mundane, not boring. We do have, as humans, a capacity limitation. We can't do these crazy fast computations and transfer 1,000 parameters in 30 seconds. We need to be more efficient so that we can break the barriers, break down those barriers, get new products to market faster, reliably supply them. So if I think about that, it's really all about enabling the full life cycle from lab to life, from research and discovery through process development, clinical manufacturing to commercial manufacturing. These are some of the solutions that I talked about today that are available now to help break down some of those barriers. And I'm really excited that I work for a company that is focused in on purpose-built, purpose-driven solutions. Purpose-built because we talked about those 5 main strategies, or those 5 main things that are important to the industry: pipeline acceleration, flexible manufacturing, operational integrity, real-time release, and sustainable operations. Purpose-driven because it's about the patients in the end and their families. And I think you're all here with me in saying that. So I would love to invite you to our booth where you can see the purple that reminds us that it is purpose-built and purpose-driven. And we'll give you some lifesavers because we're all part of a lifesaver community where we're taking this new science, this new technology, expanding what we're doing to make a breakthrough, to break down the barriers and solve these toughest challenges.
When you say Team Lifesavers, it means a purpose-driven, passionate organization that leans in together to figure out the hard things in life sciences so we can have an impact on the industry and for patients.
Thank you. Come join us and be a lifesaver. You already are.
We do have time for questions, so does anyone have a question? while people are thinking, I had a question about training and knowledge transfer. So these are complex systems. How do you make sure that the folks that buy them end up being able to maintain them and enhance them?
Oh, absolutely. That's a great question. I mean, there's a lot of different things that you can do from a training perspective. Obviously, training classes, participating in training projects. But I'm also thinking about, for an operator, for example, we didn't talk about every solution that Emerson has to offer. It's a huge company with lots of stuff. But another component is simulation. And being able to simulate things that happen on a regular basis for training, or maybe those things that don't happen that people don't really get to see. And so we have some other solutions that help with that too.
Great. We do have a question here.
Thanks. Hi, thanks for the presentation. Good job. My question is for MES. Work for a CDMO. One of our common complaints is, we did start small, but it takes a long time to make changes, especially in the clinical setting. I'm just curious on what your thoughts are today on improving timeline for those changes, and then if there's anything in the future for, really that first step into the clinical field, which is always changing, how your technology is helping with that.
Yeah, sure. Another great question. There are several different ways you could think about that, I think. One is, do you have to have everything in MES in the very beginning? And maybe it's just simple workflow that is required to help you make sure you're doing what you need to do. That's an option. We have options for that, for example. Another is there a way to break down the things that you do into repeatable and parameter-based ways that you manage that, so that when I talked about those parameters that you have to, enter as you go down the line, if you can make it parameter-based, that makes it easier to just change the parameters. Yeah. So, and have those reusable building blocks, basically, for doing that.
Any other questions? Yes.
When you were talking about the capacity modeling, et cetera, is that for you already have this tool and then you're looking to bring that in to see where it fits? Or on the sending site? Like the sending site will have some assumptions, but not maybe necessarily how it's going to fit into your facility. So like what part of the tool does that work with, and et cetera?
Yeah, sure. So there are two different kinds of tools I think I mentioned. There was one that does a gap assessment, like do you have the right equipment? Is it the right is the equipment the right capacity, et cetera. And then the other tool was looking at, if I have a model for my facility, can I fit in more batches of a new product based on this? So yeah, you can do that, yes. And then you can also use that schedule model, for example, when you're running your process, then to also further identify, now that I'm running for a while and I have more data, I can further identify where are additional bottlenecks and gaps, or bottlenecks that I can attack. And if I need a new Chrome column and it makes a difference, great. Let me go buy a new Chrome column.
Let's thank you again for your presentation. Fantastic. Thank you.